Hello everyone, welcome back to my YouTube channel. Today we are going to solve day 12 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2787, ways to express an integer as sum of powers. So let's read the problem statement. Given two positive integers n and x, return the number of ways n can be expressed as the sum of the xth power of unique positive integers. In other words, the number of sets of unique integers n1, n2 till nk, where n is nothing but n1 power x plus n2 power x plus until nk power x. Since the result can be very large, we have to return it modulo 10 to the power 9 plus 7. For example, if n is equal to 160 and x is 3, one way to express n is 2 power 3 plus 3 power 3 plus 5 power 3. Okay, 5 power 3 is nothing but 125, 3 power 9 is nothing but 27, and 2 power 3 is nothing but 8, right? So here if you just do the calculation of this one, 125 and here 27 and here 8, so you are going to get 8 7 15 5 20, 2 here 2 4 6, right, and here 160. All right, okay. Now here see example number 1, n is equal to 10 and x is equal to 2, right? So n is equal to 2, right, and we need to have the unique integers, right, such that the summation of them, if we do the summation of them, we get this output, right? So now if I do 1 power 2, I will get 1. If I do 2 power 2, I will get 4. If I do 3 power 2, I will get 9. If I do 4 power 2, I will get 16. If I do 5 power 2, I will get 25, right? I have to do the power of 2 always, right? So here I can say 1 power 2, this is nothing but 2 power 2, this is nothing but 3 power 2, this is nothing but 4 power 2, this is nothing but 5 power 2, right? Okay, so now n is equal to 10. Until 10 only we need, right? So there is no need to take this number or this number, right? Because if I just take this 4 power 2, my result itself is going beyond this 10, right? So there is no need. So only until here we need to check, right? Only until here, because maybe if my n is equal to 16, right, so then I have to check all this, right? 2 power 2, 3 power 2, 4 power 2, right? Because here 1, this is nothing but 4, this is 9, this is 16, right? We have to just find out the number of ways. So this 16 is also one way, right, if my n is equal to 16. So only until here we need to check, right? So I will simply run one loop, right, until math.power I of x, okay, until I exceed this. So I will run one loop until I get all the numbers like this 149, and if I get any number, right, which is greater than this n value, right, when I'm doing the power of x or for any integer, so I'm not going to take that. Only until here we need to find out, right? Okay, once this is done, now we have to calculate the number of ways using this simple array 149, and that is also very simple. 149 here, this is my array, let's say, right? So here n is equal to 10, this is what we need to find out. Initially let's suppose my I is here. Now here I have two options whether I want to take this one or not. These are the two options I have. So if I am taking this, so here let's say take, and here let's say skip. So if I'm taking this, my I is going to reach here, but now the remaining sum that I need is 10 minus this one, so remaining sum is 9 now. Okay, same way here if I'm skipping this, so I will have this 149, my I is going to reach here, and since I'm skipping it, so my remaining is still 10 here, right? I still need to find sum as 10. Now next time, here again I have two options, take or skip. So if I'm taking this, so 149, my I is going to reach here, and if I'm taking it, so 9 minus 4, that is nothing but 5. Okay, so 5 is the remaining part. If I'm skipping this, if I'm skipping this 4, so here I can say 1 4 9, my I is going to go here, and my remaining is still 9 from here. Okay, 9 is still remaining. All right, this is done. Now here again I have two options, take or skip. So if I'm taking this, so first 149, my I is going to go out of bound here. Same way here also my I is going to go out of bound here. So here if I'm taking this 9, so I'm going to get 5 minus 9. 5 minus 9 is minus 4, right? I'm going to get minus 4. So this is invalid, right? This is invalid, right? Because only until 10 I have to find. Now here if I'm skipping this, if I'm skipping this, so what I'm going to get, I'm going to get just 5, right? And my I goes out of mode, I am not getting 0 yet. So from here also I'm not going to return anything because my I goes out of mode. Done? Clear? Now here if you see this part, here if you see this part, so here also I have two options, take or skip. If I'm taking this, so first of all my I is going out of bound here, and here also my eyes goes out of bound here. Okay, now here if I'm taking this, so 9 was the remaining, now I'm taking the 9, so my remaining is 0, right? My remaining is 0. So this is one valid path, because in this path I am taking what, I'm taking 1 and then I'm taking 9, right? So 1 and 9, so this is one result, right? So I will just return 1 from here. Okay, one way, right? Okay, so here if I'm skipping this 9, so if I am skipping this 9, then my remaining is still 9, and then this is invalid. Okay, clear? So from this side I am returning 1, 1 goes here. Okay, overall if you see, only 1 I'm going to get from this part. Now here if you see this part, 4. Okay, so here uh, here if you take this 4 or if you skip this, so if you take this 4, first of all 149, your eye is going to go here to this position, and here also your eye goes here to this position. All right. Okay, so now if you are going to take this, so then if you are going to take this 4, then remaining is 6, and if you are going to skip this also, then remaining is still 10, right? Now here also if you see, you have two options, take or skip. So 149 I goes out of bound, and here 149 I goes out of bound. Here also you have two options, take or skip. So if you take this, I also I goes out of bound. Here also 149 and I goes out of bound. Okay, now here if you are going to take this 9, right? So remaining here 6, right? And now here in this part we are skipping this, right? This 6 is not for this, I think, right? So here what we are doing, we are skipping this, so then remaining is still 10 here, and here also it is 10, right? Okay, now after this, after this if I'm taking this, okay, so if I'm taking this, then yeah, if I'm taking this now, then 10 minus 4, then I am writing 6 here, that's why. Okay, and if I'm skipping this, so this part I have already solved now. All right, so now here see this part, if I'm taking this 9, so 9 6 minus 9 minus 3, invalid. Okay, if I'm skipping this, then only skip 6 is there. Okay, I don't need this one, also not valid, because I need 0 only, right? Here if I'm taking this, then I will get 1 as the remaining. If I'm skipping this, I will get 10. Okay, so invalid, right? So my output for this one is going to be 1 only, right? We can express n as the following, n is equal to 3 by 2 plus 1 by 2. Okay, that is nothing but 1 9. So from here I'm getting the result. All right, so this is what you need to do. Same for example number 2, and constant size is very small, right? So you can simply use this take and skip. Okay, we will use memo as well, because there may be some cases where, let's suppose okay, this is one tree, and here in this part of tree you have one array, and in this skip part there is one array. Let's suppose you have three elements in both sides. Okay, there may be some case. Now you are here at this position I. Same way here in this side also you are at this position I. Here in this side also the remaining sum that you need to calculate, let's say 25, and here also the remaining sum you need to calculate is, let's say 25, right? So now this tree and this tree is same now. After that there may be some more parts to this. So if I have already solved this tree somewhere here, so I can simply get the solution of here of it here, right? I don't need to solve it again. So that's why I'm going to use memoization. So in memoization, what are the two things that are changing? One is this index that is changing, right? At which index I am, right? This is the one thing that is changing. Okay, and the remaining, what is the remaining, this part is changing. So only I need to check this. Now in memoization table I will just add what is the remaining part and where I am at right now. Okay, so I will create a memoization table, right? And that's it, very simple problem. Okay, so now let's write the code, nothing complex here. It will not take much time in coding as well. So here what you need to do, first of all, since problem is saying that answer result can be very large, so we have to return it modulo 10 to the power 9 plus 7, right? So here what you need to do, let me just maximize the screen. So here you have to write private static final int mode is equal to 1 1 2 3 4 5 6 7 8 9. Done. And then memoization table we need to create. So here just write private int 2d, right? Because only two things are changing, that is the remaining part and your one is remaining part and where your index is, right? And the powers array that you have created, or array list, right? So first of all we have to pre-compute all powers which are less than equal to n. So here I'm just going to create one array list. Let's say list integer powers is equal to new array list, and here you have to simply run one loop. Int I is equal to 0 1, right? We have to start from 1, and here math dot power, and here I comma x, right? This value it should be less than equal to n, and here I plus plus. All right, and here you have to just write in the powers. Okay, you have to add this powers dot add, and here int change it to int. Okay, whatever the power you are going to get, math dot power, and here I comma x, right? We have to cast it to int. So this is done. So we calculate this. Then from here I'm just going to simply return dfs. Let's say this is my method, and here in this I'm just going to pass the powers that I have calculated, the remaining portion. So remaining is still 10, and right now I'm at index 0. So this is what I'm going to pass, and this is done here. All right, so here I will just define this. Okay, method private int dfs, and here I'm just going to pass this list of integer of powers. So let me just copy this here, and then I'm going to pass my n value here, int n. Okay, or let's say remaining. Okay, this n is nothing but the remaining part, and here let's say this is nothing but index. All right, so now in this few base conditions, that if remaining, right, if it is equal to 0, then in that case simply return 1, right? Because we found a valid combination. All right, if my remaining, okay, if it becomes less than equal to 0, right, this case, or my index reaches out of bound, right? So I can say index is greater than equal to powers dot size, right? So in that case just simply return 0, because there is no way from there, and this is done. Okay, and then you have two choices. One is take this power or skip this power. So if you are going to take this power, right, so if you are going to take this, so you have to call this again dfs, right? And now if you are taking this, so you have to here pass powers, and now remaining you have to subtract, right? Remaining, spelling mistake, remaining, okay, remaining minus powers dot get, and here you have to pass index, right? So you have to just subtract that from the remaining. Okay, you have to pass the new value of remaining, and index is always going to be incremented. So here I can say index plus 1. So this is first choice. If you are taking this, choice 2 is to skip. So if you are going to skip it, so here then you have to mention here dfs, and here you have to pass the powers, and remaining will remain same, right? In this case there is no change in the remaining, right? Again, spelling mistake I'm doing here, remaining, right? And here remaining will remain same and index is going to be incremented. So you are going to get two results from here, right? So we have to, what we have to return, we have to return the here the total values, okay? Take and skip, how many ways I'm getting from take or skip. Okay, so I have to just do the addition. So I can say take plus skip, right? And here just divide it with mode, take the mode with modulo, right? Okay, that's it. So this is done. Now we can also use the memoization that we have created here. So in memo only two things are changing, right? One is the remaining part and one is the powers. Okay, we have to iterate over the powers. So here memo size that I'm going to pass is nothing but new int here n plus 1, because until if n is 10, so until 10 we have to check, na? So 0 to 10 all values we have to check, and here I have to just pass powers dot size because we have to iterate over all the powers, right? Where I am my current index, all that stuff, right? So this is done, and here just update all the rows in my memo as -1 initially. So this is a basic thing that we do in this. Okay, so here I'm just going to write arrays dot fill, right? And what you are going to fill, you are going to fill all the row with -1 initially. That's it. All right, so here whatever the result that you are going to get now here, so just update this memo here, memo of remaining and here index. So I'm going to update this, right? And here whatever the value that I'm going to get, okay, just change it to int also. Okay, int, and here just pass this here like this. Okay, so in the memo I have added this. All right, okay, this is clear. And here one base condition that if my memo and remaining index value, right? If memo and remaining index value is not equal to -1. Okay, so initially we have given -1, so maybe it got updated here. So if it is not equal to -1, again when I'm calling this method, so in that case what you need to do, in that case you have to simply return the result of this. That's it. Okay, this is the use of memoization. Now let's run it and see if the encode issue will try to fix that. So see, all the test cases has been accepted, right? Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.